In this video, I am going to describe our 2.2 assessment moving through sports and exercise. I am going to analyze my strengths and weaknesses of my forwards role using the biomechanical principles of angular momentum, force summation, and balance and stability. I will also apply all my knowledge of anatomy. One of the strengths of my forwards role was my preparation to my execution phase. I used flexion within many of my joints such as my hip, neck, and spine. I felt that in my preparation phase, my hip flexion was my best strength within the movement. This helped me prepare to get into a good motion for my forwards roll. Flexion is decreasing the angle between two bones at a joint. Therefore, hip flexion would be bringing my leg close to the sagittal plane. In the start of my movement, I had my knees slightly bent and my hips, neck, and spine were flexed. Having these joints flexed helped me gain my angular momentum to propel my body into the movement around the axis of rotation. Angular momentum can be defined as the movement of a mass around an object and is calculated by multiplying angular velocity with the moment of inertia. The moment of inertia is the measure of resistance of an object due to its change in angular speed. The downwards angular momentum I am applying in the start of my movement provided me with the momentum I needed to rotate my body mass in a forwards roll motion. In the start of the movement, I extended my arms to help me gain angular momentum and velocity, and I was executing my movement well. I pulled my arms in to lessen my moment of inertia. This meant I was able to complete the movement from my preparation to execution without applying any more force. I also use force summation to increase the effectiveness of my movement. Force summation is defined as using as many muscles and joints as possible to create force. Force summation uses a sequence of using big muscles before small muscles. By using my big muscles, I have managed to gain the power and momentum I needed to complete my preparation to execution movement. By using my big muscles such as my iliopsoas, gluteus maximus, quadriceps, and hamstrings, this has helped me gain the power to perform this movement. The movement occurring in this preparation to execution phase is hip flexion. The agonist muscle within this movement is the iliopsoas. The fibers within this muscle in the movement will therefore be contracting and shortening. The antagonist muscle is the gluteus maximus. The fibers within this muscle will be relaxing and lengthening. The joint used in this movement is a ball and socket, which is commonly known as a synovial joint. This is a smooth ball-shaped bone structure that fits into a cup-like socket. This allows for multi-directional movement and rotation. The ball and socket in the hip joint is made up of more specifically the actabulum, which is the socket in the pelvis, and also the femoral head, which is the ball of the femur. The articulating bones around the hip are the femur and pelvis. These help with decreasing the angle, causing the movement of hip flexion. One of the weaknesses within my movement of my forwards roll was my execution to recovery phase. I became off balance and unstable in the end of my movement and was unable to execute an accurate finishing of my forwards roll. Balance and stability is the main biomechanical principle I'll be referring to analyze my weaknesses. Balance is the ability to maintain the line of gravity within the base of support with minimal postural sway. Stability is your body's ability to return to a desired position or trajectory following a disturbance. Within this key biomechanical principle, there are three main components, in which consist of center of gravity, line of gravity, and base of support. Center of gravity is defined as the point at which gravity appears to be acting upon an object or person. This is for the most part the same as the point around which the mass of an object or person is equally distributed in all directions. Line of gravity is an imaginary vertical line from the center of gravity to the ground or surface the object or person is on. It is a direction that gravity is acting upon the person. Lastly, your base of support is the area around the outside edge of the sections of your body in contact with the ground or surface. When the line of gravity is held within the base of support, an object or person is defined to be stable. And when the line of gravity falls out of the base of support, it is said to say the person is unstable. We see this during the execution of my recovery phase, as my center of gravity and mass does not fall within the center of the axis of rotation. Therefore, my line of gravity is too far forward from my body, causing me to become off balance and struggle to control my movement. Also in my movement of my recovery phase, my line of gravity falls out of my base of support. However, as I stated above, in order for an object or person to be balanced, the line of gravity needs to stay within my base of support to hold the law of being physically stable true. Therefore, not being able to keep my line of gravity within my base of support didn't allow me to execute an accurate forwards roll. In order to biomechanically improve, I would ensure to widen my base of support and lower my center of gravity, which in theory would put my center and line of gravity in the middle of my body and allow me to become more stable and balanced, which would then lead to a more effective and accurate boards roll. As we see in the image, my base of support is very narrow. This makes it very difficult to gain power, control, and balance. Therefore, I am more likely to be off balance. However, not being able to execute my forwards roll also links to angular momentum. In this phase, I had too much angular momentum and velocity, which led to me becoming unstable and unable to execute an accurate finishing of my movement. In my execution of my recovery phase, it is clear to see that I applied too much angular momentum and velocity. This meant my limbs were closer to my axis of rotation, which meant I had more angular momentum and less rotational inertia, therefore causing me to jump forward and become unstable in the end of my recovery phase. To improve this weakness, I need to move my limbs further away from the axis of rotation, which will allow me to distribute my mass evenly around the axis of rotation to ensure a smooth finishing to my forwards roll. Anatomically, when I am performing my forwards roll, I am using knee flexion. The knee is a common class hinge joint, which is a synovial joint. Hinge joints are made of two or more bones and can only move along one axis to flex or extend. The bones are covered with a thin layer of strong and smooth articular cartilage, which decreases the friction forces. The synovial fluid will lubricate the articulating bones, which are the patella, tibia, and femur. When the knee is in a flexed position, the angle between the femur and tibia will decrease. The agonist muscle in this movement will be the hamstring. The fibers within this muscle will be contracting. However, the antagonist muscle will be the quadricep. These muscle fibers will lengthen and relax. When I am performing the movement, the articulating bones and antagonistic pairs of muscles will work together to help decrease the angle to bend my knees and help me execute an accurate forwards roll.